So, final installment for this one is going to be the cool electric motor I designed. Concept I designed. I don't have the actual working prototype. You think I have money? I don't have money. I don't have an income. So anyways, moving on. Now, getting into this, it's a charge field, electrostatic, headphones with a electromagnetic repulsive coil field, radial axial flux motor. Okay. So, caveat, the radial part can shrink. We use a circle that can collapse. If you don't know, there are circles that can expand and collapse. They slide. Tubes can slide inside of tubes, like we've said. And then we have a roller bearing on a hydraulic ram that can then, simply just squeeze it in on these rods that are there, that then are these, electromagnetic coils that are just, and then, so that way it can then slide down into the tube and still have the radial part and the axial part still perform as necessary, like you want. The charge field part is a bit weird, like electrostatic charge differences are usually the copper. I know. Copper? What? Like you already have for the coil? What is this? And like this thing that's going like, I'm a ground. And normally they're not able to produce much of an effect, typically. But to that I go, there are things that do produce a very measurable increased degree of movement effect. They're usually an insulator between two fields that has a sudden changeover, or it builds up and then drops off like a supercapacitor. That is that. And so, because it's possible to do that with the copper, effectively, and the rod, more or less, and the housing that also houses the copper coils for those coils, you have the ability to make a fairly pronounced charge field difference that can spin radially. It's just getting it close enough, which isn't terribly difficult, but then it's kind of is, you know what I mean? It's really one of those catch-22s where you got to get it close enough, and you have to use these woven, instead of a field like that or like this, you have to do a serpentine, and then a serpentine, which is actually doing that kind of like circle down it, and then you have to do another weird diagonal opposite serpentine through that other like snake, let's say horizontal snake, and then you have a serpentine that's coiling effectively around that. Then it has a opposite diagonal serpentine that is not horizontal, it's more of a vertical, which is a weird thing to do. Okay, if you don't know, you have to do that to be able to just make charge fields that are impeccably precise and very, very strong and can move along the length of the serpentine with the copper. And these copper plates basically are no longer just a coil around a rod. You have to do the same thing. And the rod itself is a brushed motor. Happens to have the contact where you will have your electron flow, basically, through it. And so, that allows for an incredibly close area and very precisely to within a few degrees of an inch and angle, of along the length of those coils that are embedded into plates. You have to embed them, and then I have no need for magnets, but then if I correctly do regular coils within that, and then able to produce a much stronger, spikier electromagnetic area that actually, because of that coil that it's attached to, produces a charge field next and around it. And so if you do that correctly, you then have a charge field and electromagnetic repulsive radial axial flux motor. It takes a long ass time to get there. Sorry, 5 minutes, you couldn't watch for 5 minutes, I guess. But there you go. It works out fairly well. Some of you probably did, but I imagine some of you were like, this one, yeah. He doesn't have any cool graphics with my Chromebook that doesn't have in any way the ability to make graphics, and I have no editing capability, which is why it's all raw and just straight out. And I need to get an editor, but with what money? So, just be quiet out there. I'm on ACP, an affordable connectivity program, snaps and all this other stuff. So things are kind of free right now. That kind of stuff. But the point I'm trying to make is that I designed it specifically for that car that I was talking about, that car generator design and concept, which I can still use regular salt batteries to basically store a little bit more charge and use this motor on each wheel or within a hub axle that goes to each 4 of the corners of the car, or just the rear. Regular axle, which would be just fine, truthfully, because I can stick 2 just like Koenigsegg did and go like, burr, 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 I am super strong, powerful, fast guy with my charge field, radial axial flux motor, charge motor thing that's electrostatic and stuff. That's the right insulative, and it's the housing, it's the properties of that darn housing and everything else, which are actually really good against heat, because it keeps the heat within inside of the coppers, but it also makes it a very strong charge, electrostatic charge field as a result of that. It's basically a plastic sort of insulator, ceramic, more or less, that they use for that kind of a concept and design I just don't remember where I saw it, but the point is, you'll have to find it. Plastic will do, actually, though. It should still give you a degree of significant charge field that basically is analog / you control it with the electromagnetics to basically make that work the way it does. So, you have to do it that way. Yeah, I know, right? Isn't that because then it dumps when the charge fields basically get close to each other. It then dumps as electricity into the next coil, and that's kind of the reason why it works so darn well. You have to hit several areas and then let it, basically build up, and it'll do it as quickly as you can feasibly do, and then shrink it. And it's an electromechanical analog-esque design that's got some intelligence, and it's kind of like a coil railgun concept using electromagnetic, and then the thing passes, and then whoop, with charge fields. And then you have the shrinking of the... Anyways, point is, it's a very highly efficient motor. Very highly efficient. You should definitely do it. Go ahead. It's an open source design. It's my design. Put my name on it. Please contact me if you do. If any of these designs interest you, please get my name out there. Please contact me. Please do that. I would love to collaborate and work with you. You have no idea. I have no income. I have no ability to make this stuff. I'm just really, really smart at that kind of stuff, imaginationally wise. Now, it's a wonderful design, a wonderful concept. I wish I could give you some super cool, fancy, things, but I have a Chromebook, and I don't have the computer-aided design in any capacity. So these are all in the old brain noggin thing. So you kind of gotta deal with that. But it's a fairly efficient design for what it's worth, and it mostly just improves the horsepower and ultimately reduces the energy input, because you have specifically energy only when and necessarily you want it to be at. which uses the energy from it to effectively create the charge field attractive, repulsive design, like a regular iron or a regular magnet, in electromagnetic coil design. So the charge fields are the magnet. Effectively, they create attractive forces, typically. And then also then go, oh, I'm close enough that I go, I'll allow electricity, and then the field collapses. A MOSFET, field effect occurs from the capacitor, and then it allows for it to go off to the next one, or the next one, or the next one, or the next one. And you get the picture. So it's like, and then shrinks. And explaining it too much, I'm awkward now. But it's really, really cool. I feel it's really a neat little trick of engineering. And I was like, there's technically a way to put this into the opposing blades if you do it the right way, which can give you the rotation, thing that you're looking for. That one's a little bit of a different design than the regular vacuum, but it's possible, and as a result, it then improves efficiency by having the air actually help create electricity, while this also produces a measurable degree, as you pump it in, continuation of an effect for air blowing through, and you get, of course, your standard vacuum. Then that improves efficiency again, and then you get your work motion energy. And that's kind of where I decided to go and say, hey, this is another way to make those electrons do a lot of good work for you with the plane stuff, and that would be cool. Because that's probably good. And then I was like, right. And then there's these coils with copper, and I shove plasma through. Because there's nothing saying I can't do that, especially over the fuselage of an airplane. And then I can put this as the electrostatic part, and then basically continually fire plasma faster through these coils and heat it up too. And then as it comes into this boundary layer, and then I collect some more air, and then I can have that be the charge, electron electrode kind of area. That's like the wind that's going over it produces a charge difference, and then it collapses with the plasma that then gains that electron back, and I go, brr, more thrust, woo, more thrust, yay, fun, with these turboprops and some solar panels and some band gap increases and some batteries, and then now I've got electric planes, whee. And that's basically what that was, because I was like, why do you use hydrocarbon, blah, blah, blah. You can use my design. Hydrocarbon, stupid. Use the Lemke design. Anyways, bye. Yeah.